Okay, Year 9, we're about to embark upon a really interesting part of mathematics now, and that is the proof. Now, the proof in mathematics is very rigorous, which means you must make sure that you show all your steps clearly and you label everything. So I'm going to do a proof in a minute. And I told you I'd do this in a previous one where I proved that the angle sum of a triangle was 180 degrees. So let's set that up. So if I just construct a triangle of any, and this is going to sort of give me an equilateral one, which I don't really want, but that doesn't matter. When you try and set it up, whenever you do a proof, try and make the conditions of the triangle such that they're not equilateral, or whatever the shape is, that it's not regular, unless it specifies. So I've just got any old triangle here, and I'm going to label this triangle A, B, C. So whenever you start a proof, it's sort of like a science experiment in that you're going to start with an A. So over here, prove. Now I'm going to put some symbols in here. So I'm going to call this X, Y, and Z. And because I'm using algebra, it won't make any difference. And my proof is going to be prove that X plus Y plus Z equals 180 degrees. Okay, so the first thing I'm going to do is I'm going to construct. So whenever you're going to do anything, you must write what you're doing. So I'm going to write down here, construct a line through B parallel to A, oh gee, that's awful, AC. So what are you doing? I'm putting a line through there that is parallel to there. Now I've created two more angles here, so I'm going to call them different letters. So let's call this one S and T. So now I'll begin my proof. So Z equals T. Those two angles are equal. Why? Because they're alternate. So Z equals T, alternate angles on parallel lines are equal. Now by the same definition, and note that I keep all my letters, I'll see it later, all my letters on the same side as different things. Now X equals Z for the same, X equals S, I'm going to write that a bit further down. X equals S for the same reasons. And you can see it here. There's this Z. And they're the Z, S and X are the same. So now, S plus Y plus T equals 180. Why? Because it's on a straight line. And they're all supplementary. But x plus y plus t also equals s plus y plus t, just from above, because x equals s and, that should be z, and z equals t from above. Therefore, and we use this symbol, therefore, x plus y plus z equals 180 degrees, which is what we're trying to state. And then we write this thing, which is quadratus demonstratum, QED, which was Latin for as I have shown or as I have demonstrated. And that's a formal proof. And you must make sure that all your steps are explained, clear, and concise. Now, congruency, because that's the major form of proof. Two shapes are congruent when they are the same shape and the same size. You might like to write that in your notes. Two shapes, same shape, same size, congruent. That means they have the same angles and the same lengths on their sides. Now, when we prove triangles are congruent, there are 4 different proofs. Now, essentially, one is the same as the other when you see it. So, I want you to make sure you write your notes here. So, the 4 tests for congruency or triangle congruence. We're going to paraphrase these ones. So the first one, side, side, side. Now when you're doing proofs, you've got to be very particular about how you write things. But in mathematics, we can bring that down to side, side, side. And that's all you need to write. But all it means, if the 3 sides are all the same length, then your triangles are congruent. That's a really easy one. So if you've got 3 sides and you know they're all the same length, congruence. The next one is side angle. Oops. Side. And we'll write that as SAS. You can use that code. But I want you to put a dash under the A, because when you do this, side angle side means that the angle must be in between the 2 sides. So one's 2 sides and the included angle, that is the angle in between them. And that's very, very important. The angle must be between them. So as you can see here, in this one, this and this are the same because the angle is between the 2 sides that you have been given. In these two, which we're going to look at in a minute, So the angle must be between. It must be the included angle. This is very important. All right. Angle, angle, side. If you've got 2 angles and a side, but again, we'll dash under that side, it must be the corresponding angles. So if you've got 2 angles in a triangle, you've essentially got 3, because you can use the angle sum to find the third. So if you've got 2, you've got 3. But it must be the corresponding side. It must be the side that is in the right position. And you'll see somewhere we don't do that. The last one is just another version of side, 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 because it's right angle, hypotenuse. And side. And there's no special conditions with that. As long as you've got a right angle, a hypotenuse and a side, RHS, you've got it. And essentially what that means is if you've got a right angle, a hypotenuse and a side, well, by Pythagoras, you can work out the third side. So it really is just another version of this. Now, there are our 4 tests for triangle congruence. So if we look at some of these questions, and we're not going to spend very long on these, which congruence test would be used for these? Well, here you can see you've got a side and a side and an angle in between and a side. So that's side angle side. Here you've got 2 angles. You can see them there, they're the same. And the side that is between them. So that is angle, angle side. Here, right angle, the hypotenuse, and another side. Beautiful. RHS. This is a tricky one because you're thinking, oh, right angle. And you're right, it is a right angle, but you don't have the hypotenuse. You do not have this side, so you can't use RHS. What you've got though, is you've got this side and this side and this side and this side. So this is actually side angle side. The fact that it's a right angle makes no difference. So what we have here, SAS, AAS, RHS. Easiest one, side, 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 side. Oh, SSS. So that's essentially what you're looking for. So let's go on to some proofs, because that's where we're going to be getting into this. So we'll jump down here and we're going to 10E question 6. And this is the important bit. So this is what I want you to be able to do. How do you prove? Now remember, you are going to prove congruency. Now, here's some stuff that I did previously. So I'll just clear a bit of space. And righto, that should be enough. So the question 6. And this is where you've got to truly take your time. So really take a little bit of effort here. So question 6A. Now there are some symbols here. So the first thing I want you to do, draw the diagram. The diagram is terribly, terribly important. So as neatly as you can, freehand will do. That looks like it. Put all the information that you've got on it. And that side and that side are equal. And that side and that side are equal. Put your labels on. So what have we got here? D, E, C, A, B. State what you're trying to prove. Prove triangle A, B, C is congruent, and that's what those three lines mean, to triangle E, D, C. So let's make sure we understand what that is. These three symbols means that they're congruent. And that is just a symbol for the triangle. We're going to be using a little bit of shorthand, so you need to be good at this. So I have to prove that the triangles are congruent. Now remember, my four different types of proofs. I can have side, side, side. Well, I don't have this in this case. I've only got two sides. I can have side, angle, side. I can have angle, angle, side, or I can have RHS. Well, I can't have RHS. I don't have a right angle there. There's no way I can prove there's a right angle. Plus, I don't have an hypotenuse. I've only got two sides. So it's either this one or this one. Well, I can't use the top one. But this one here, side angle side. What about these two angles? Well, yes, they're equal. And you're allowed to draw on the diagram, especially if it helps you. They're vertically opposite angles. So I can prove this. So this is how we set it up. Now try and write everything about one triangle on the left-hand side and one triangle on the right-hand side. And because I've already put ABC on this side and EDC on this side, I'm going to put all my information about ADC over here and all my information about EDC over here. It just keeps everything logical and ordered. So let's look at triangle ABC. Well, what do we know? Well, we know that BC equals, well, which one is equal to that in the triangle EDC? Oh, CD. Well, how do you know that? Well, it was given. The information was given on the diagram. We also know AC equals CE. Look at the symbols. Again, it was given. We didn't have to, they told us. And finally, we know that angle, so we need our angle ACB, which is this angle, ACB, equals DCE. Oh, Dalshire Evans. This angle. And how do we know that? Well, this time we actually have to state a rule, because vertically opposite angles are equal. Therefore, triangle ABC is congruent to triangle DCE, but we've got to write a reason, and we can use our little annotation or abbreviation for this, side, angle, side, because we've got two sides and the angle in between, and that is your proof. Why don't you give 7 a go? I'm going to give 7 a go, but I want you to have a go at it and then try and watch it. So pause the video, give it a crack. So here's 7. So hopefully you've given it a go. Again, we're going to be using one of these. So 7. Let's have a look at the diagram. Very similar diagram to the one previous. So draw your diagram. Label it. What have we got? A, B, C, D, And what do we know? Well, they tell us that that's 90 degrees. They tell us that that and that are the same. And they tell us that that and that are the same. Okay, what have we got to prove? We've got to prove, so as our diagram with our information, we've got to prove that ABE is congruent to CBD. Prove A triangle ABE is congruent, that's what those three symbols mean, to triangle BCD, CBD. Same thing. Okay. Well, what do I know? I've got two sides. Remember, I have to use one of these rules. For congruence of triangles, I'm going to need one of those. So I've got two sides. The angle's not in between, and it is a 90 degrees. But again, if that angle is 90 degrees there, if that angle is 90, well, then this angle is 90 as well, because it is vertically opposite. And now I'm pretty sure I've got a right angle, I've got a hypotenuse, and I've got another side. So I think I'm away. So the first thing, again, I'm going to write everything about triangle ABE on this side and CBD on this side. So first thing, and I'm going to try and keep it in order, I need my R, my right angle. So ABE equals 90 degrees, which also equals CBD. Well, and why is that? Vertically opposite. Angles are equal. What else do we know? Well, I know that AE, let's look up there, is a hypotenuse and also equals DC. So they are hypotenuse. And how do we know? Well, it was given. We were told. They put the symbols on. Finally, I know that BE equals BD. So it's BE equals BD. And that was given. Therefore, triangle ABE is congruent to triangle CBD. Why? Because we had a right angle, a hypotenuse, and a side. And then throw your little QED to show off, and you've got it. 6, 7. Now, have another go at one yourself. Remember, you're only meant to do 6, 7, 8, 9, 10. So here we go. I've got a parallelogram. All right. So there are a couple of ways you can do this. And question 8 takes us a bit further because it says hence prove. So 8's important to do. So stick with me. So here's question 8. And let's draw it. Okay, so there's my parallelogram. And let's put a line in for the diagonal. And let's label it A, B, C, D. Let's put our symbols on. That's equal. That's equal. That's equal. Whoops. Let's undo a couple of them. That's only got one. That's got two. And that's got one. Okay. So here we go. Write down what we've got to prove. Now, we don't even know that that's a parallelogram. We don't know. It is a parallelogram. You probably have to prove it. We don't need to know it's a parallelogram. We're to prove that ABD is congruent to CBD. Prove that A triangle ABD is congruent to BCD, CDB. Triangle CBD. Right. So, what do we know? What rule are we going to use? We've got a choice of these four up here, remember? Now, I don't have any angles. And even though we know it's a parallelogram, you can't do that. You've got to prove it. So this would be a nice one to say, prove that is a parallelogram. And that's what they're asking us to do in the second part. They're actually asking us to prove that AD is parallel to BC. So we can't state that it's a parallelogram. We'd have to prove it first. So how are we going to do this? By proving that those two triangles, ABD and CBD, are congruent. Well, how do we do that? Well, we've got this side and this side being equal, and we've got this side and this side being equal, and this side in the middle, it's the same for both triangles. Oh, so I've got side, side, side. So here we go. Again, I'm going to write everything about triangle ABD on here and everything about triangle CBD over here. So AB equals DC given. It was in the information. AD equals BC given. Okay. Well, we've got some stuff here from previous, so let's get rid of that. Right. Now, this next one I'm going to write in the middle. BD is common to both. And that's a symbol we use to indicate, oh, that's common to both. Therefore, triangle ABD is congruent to triangle CBD. Why? Well, side, side, side. We've got three sides. Now, it then says prove that AD is parallel to BC. So now this is a lot harder than a lot more involved than what you think. Prove AD is parallel to BC. Well, to prove parallel, I need something that indicates that the sides are going at the same gradient. And what can I do? Well, if this angle and this angle are equal, well, they're alternate angles. Okay. And they are equal because they are corresponding angles in both triangles. So look at this triangle. and that little angle symbol is between the squiggly line and the one line. And now look at this triangle, and that little alpha symbol is between the squiggly line and the one dash. So they are in the same position in both triangles. So here we go. Well, and I have to use the right symbols. A, D, B equals D, B, C. Why? Because they're corresponding. They are in the same position, angles in congruent triangles. They are the corresponding angles in the congruent triangles. Right. Well, if they're equal, well, hence, I might go therefore. Therefore, AD is parallel to BC. Well, why? Because since ADB equals DBC, and they are alternate angles on parallel lines are equal. So we get our proof. So how did we do that again? Let's look at this. Oh, if this goes back to the beginning, where's it going? Oh, that's there we go. Well, that's other stuff. Here we go. So what did we do? We proved that both the triangles ABD and CBD were congruent. How? By showing that three of the sides are the same in both triangles. Now, to prove that AD is parallel to BC, by showing that the alternate angles are equal, well, then the lines must be parallel. And the alternate angles are equal. Oh, I've got an L in parallel. The alternate angles are equal because they're corresponding angles in congruent triangles. Therefore, AD must be parallel to BC. Now, let's have a look at some of the other ones. Now, I'm not going to do them all, but questions 10 and 11, I might make a separate video. Prove that ABD is congruent to CBD. Well, let's have a look at this. How are you going to do it? So it's always a good thing to have a look at things. So this side and this side are equal. This angle and this angle are equal. And this angle is common. This side is common. So you've got side, angle, side. You've got the angle in between, two sides. Bang, you can prove that. Now, if they're equal, if they're congruent, that also will mean that that angle must equal that angle. But you don't just have to show that those angles are equal, you have to show that it's perpendicular. Well, you go, well, they're equal, and not only that, they're on a straight line. And if they're equal and they're on a straight line, they must both be 90 degrees. Let's have a look at this one. How would you prove this one? ABD, so this triangle here, is congruent to this triangle here. CBD. Well, what have we got? We've got two angles, bang, bang. We've got this common side And we've got 90 degrees here, which means we must have 90 degrees there. So we've got angle, angle, side. Now, once you show that those two triangles are congruent, so this one and this one, well, then you know that the corresponding sides must have the same length. Therefore, that side and that side must be equal. Hence, that triangle must be isosceles. But you go through the steps and show your working. Good luck.